Good morning, algebra students. Welcome to lesson 2.5, Solving Problems Using Simultaneous Equations, recorded for us on pages 61 to 63 in our textbook. Today we're going to be using the different methods, applying them to solve real-life problems that can be represented by two simultaneous equations. When we're attacking these kind of problems, we follow the certain steps. I'd like you to record these steps in your notes. I'll be looking for them. So step number one, of course, it's pretty logical. Read the question carefully and identify the two unknown quantities to be found. Typically, you identify them in the order that they appear in the word problem. Number two, then use the letters X or Y, or any letter of your choice, to represent the two unknown quantities. Number three, express some other quantities in the problem in terms of X and Y. Simply that means they're going to talk about these two unknown quantities, and then they're going to set up certain conditions for them, which you will have to put in a term of X and Y. Then number four, after that, you will form your equations, the two linear equations based on the given information. And five, you will solve the simultaneous equations. And finally, six, write down the answer statement. That's where you would answer the questions with the appropriate labels. Note, check the answers using the original conditions to make sure that you have calculated correctly. Pause the video, get these all written down, and when you're ready, we will begin on the bottom of page 61 with try it 14. It's a crack in my table. There, it's gone. All right. Moving on with try it 14, the bottom of 61. Of course, you can also read example 14 to kind of get you in the groove of it. But I will read try it 14. I have to admit, when I first read it, I thought, oh my goodness, what are they even talking about and why would I want to do it? But it's there for our learning pleasure. So here we go. The sum of the digits in a two-digit number is 13. And I'm just going to stop a minute. Like if we would add the digits in the number 13, the 1 which is in the tens place and the 3 which is in the ones place, that particular sum would be 4. So let's just go back and kind of think this again, just so you can kind of wrap your head around it. The sum of the digits in a two-digit number is 13. If the digits are reversed, the number formed is 45 less than the original number. Find the original number. Okay, so here we go. First of all, we got to determine X and Y. Because it's a two-digit number, we're going to break it apart into two quantities. We're going to have X be the tens digit and Y be the unit digit, or in this case, the ones digit. And this would be of the original number. So X and Y refers to the original number. X is in the tens place, Y is in the ones place. That's the first step. So the original number, because X is in the tens place, would be 10 times that digit plus Y. Because Y is in the ones place, it doesn't need to be multiplied by anything. So the original number is 10X plus Y. Moving on. The number formed by reversing the digits, that would mean the digit in the ones place moves to the tens place. So now we have 10Y plus x, because the digit in the tens place now moves to the ones place. So here's the original number, 10x plus y. Then when you flip them, it will be 10y plus x. Whoops, turned the page too soon. So far, I've done the sum of the digits. I haven't done the sum of the digits yet, but I've had the original number and then I did the reversal. Now I can put these two things into the additional information because it says the sum of the digits in a two-digit number is 13. So from the given information, x plus y, now we're going back to just the digits, not the 10x plus y, we're just going back to the digits. So the x plus the y is 13. That's our first equation that we're coming up with. The next sentence says if the digits are reversed, the number formed is 45 less than the original number. So now they're going to bring in this original number when the digits are reversed. So that will look like this. We'll take the 10x plus y and we'll subtract the new number when the digits are reversed, 10y plus x. So we subtract because we are looking for 45 less. So 45 is the difference. So that's why I use the 10x plus y and the 10y plus x, because we're looking at the original numbers and then the new number when the digits are reversed. Up here we're just looking at single digits equaling 13. Here we're looking at actual numbers and finding the difference. So that's our second setup. Okay, so now we have some simultaneous equations. So from the second equation, we're just going to simplify it. So since we're subtracting, we're actually going to be adding the opposites. So we're going to add and making 10y negative 10y, and we're going to add a negative x, okay? It's still going to equal 45. The difference does not change. At this point, we'll combine our x's, which is 10x and negative x, and we're going to add to that the y's, y plus negative 10y. Again, the difference is still going to be 45. Continuing our simplification, we have 9x plus a negative 9y equals 45. So basically, adding a negative is just subtracting. So 9x minus 9y equals 45. I cannot subtract this because of the x and the y. I can't just make that 0. I have to actually now reduce these, get rid of the 9's and the 45. They're all divisible by 9. So I divide through by 9 to simplify it further. And I'm left with x minus y equals 5. Now, the next step is I'm going to take equation 1 and add it to equation 3. And equation 3 is, let's see, where did equation 3 go? Right here, maybe? Well, equation 1 is x plus y equals 13. Yes, and I did not label this. This is actually the next equation that we made. That's where I get the 3 from. And then I'm going to add to that x minus y equals 5, and you can see why I want to do that. So I end up with 2x, and of course the y's eliminate, equal 18. Divide through by 2. X is going to equal 9. So now I have one value. X is 9. turn the page. This takes up a lot of room. I just brought the x equals 9 to the top of this next page. And now what I want to do is take that first equation and put it into, actually subtract the third equation. So x plus y equals 13. And that third equation, now I'm going to subtract it, which means I'm going to add the opposites. So I'm going to add a negative x plus a y equals negative 5. Doing it that way, the x's eliminate, and I'm left with 2y equals 8. Divide through by 2, y equals 4. So the original number is, x is in the tens place, 9, and y is in the fours place, or the ones place. 4, I said that really goofy. 4 is in the ones place. So my number is 94. Now going back to the problem, it says the sum of the digits in a 2-digit number is 13. 9 plus 4 is 13. And if the digits are reversed, it would be 49. The number formed is 45 less than the original. So 94 minus 49 is 45. And that works. So there's my answer. So the original number is 94. Interesting thought process. Okay, moving on, we have our next problem, try at 15. And I put that on a different page because try at 16 actually took a lot of space. So here we go. So try at 15, we'll read that at the top of page 62. And of course you can look at exercise 15 too, just to get another look at a different type of problem. But try at 15 says, a shirt and a skirt cost a total of $138. 3 shirts and 2 skirts cost $331. Find the cost of a skirt, one single skirt. So, since it's talking about skirts and shirts, or shirts and skirts, and shirt was mentioned first, a shirt is going to be X dollars, and the skirt is going to be Y dollars, and this is what we're going after. We just want to know what one of those is going to cost. So that's our first step. Our next step then is to form our first equation. So one of each totals 138. So x plus y is 138. Then we're told 3 shirts and 2 skirts cost 331. So 3 of the x's plus 2 of the y's is going to be 331. So that's our second equation. So there's our simultaneous equations. So now we start solving. So to make the y's the same, I'm going to multiply the first equation by 2. So I'm going to multiply all of the parts by 2. So I go ahead and do that. 2 times x plus 2 times y equals 2 times 138 equals 2x plus 2y equals 276. There's my third equation. Now I'm going to subtract. After looking things over, I'm going to decide to subtract, take equation 2 and subtract equation 3. I do that because equation 2 is a little bit larger. So I line them up like that. And remember, when you subtract them, you end up adding all the opposites. So it becomes plus a negative 2x plus a negative 2y equals a negative 276. So going ahead and combining those, the y's of course eliminate. I'm left with x, and that's going to equal 55. So x is 55. I'm going to take that x and substitute it back into equation 1. So I'm going to end up with 55 in x's position plus y equals 138. Evening out the sides, I subtract 55 from both sides, and y will equal 83. Therefore, again, I go back, I just need the cost of the skirt, which is y. The cost of the skirt is $83. Remember, you can stop and rewind and re-listen as often as you need to get these problems. Going on to number 16, which is the most complicated of everything. Requires a lot of steps. It's one of those speed of the car businesses. So here we go, number 16 on page 63. Try it 16. Of course, you can get a similar situation by looking at example 16 and going through the solution steps. Try it 16 reads like this. Cars A and B move uniformly across a straight road and are 8 kilometers apart. If they move in opposite directions, they will meet after 4 minutes. If they move in the same direction, car A will overtake car B after 20 minutes. Find the speed of car A and the speed of car B in kilometers per hour. Okay, so you kind of see already the meeting after 4 minutes is going to be one equation, and the meeting after 20 minutes is going to be the second equation. It's given in minutes, but they want kilometers per hour. So I need to know how many minutes are in an hour, and we'll be working with fractions. And I have my two quantities, car A and car B. And then we have that 8 kilometers apart business, okay? So all that information. So the speed of car A is going to be our x value in kilometers per hour. The speed of car B is going to be our y quantity in kilometers per hour. And of course, we're going to remember that there's 60 minutes in an hour. Moving on. So the first scenario is about meeting after 4 minutes. They both meet after 4 minutes. That means 4 minutes out of 60 goes with the x, and 4 minutes out of 60 goes with the y. We're adding them together, and it should total the distance apart, which is 8. So that's our first equation. I'm not going to reduce this right now, okay? Our second equation would be the 20 minutes that lapses. But now they're going in now they're going in the same direction. So the opposite directions they're going to meet there, we add, going in the same direction, they'll come up again, we subtract. So we have, again, because the time is the same, it's 20 out of 60 minutes for x, subtracting the 20 out of 60 minutes for y is going to equal 8. Now we have our two equations. Again, I haven't done anything with the fractions at this point. I will eventually. But at this point, I thought I'm just going to leave well enough alone. So number 3, now it's time to eliminate the denominators. Eliminate them. So I'm just going to take my first equation, multiply through by 60 to get rid of it, and then I will be left with 4x plus 4y equals 480. And then I'm going to do the same for the second equation. I'm going to multiply through by 60 to get rid of those denominators of 60 and those two quantities, and I'm going to be left with 20x minus 20y equals 480. So put stars by here because these are the equations that will probably be most simple to work with instead of the ones with denominators in the fraction form. Okay, so that's the prep work so far. Now, instead of reducing fractions to simplest form, I'm going to reduce the equations to simplest form. So in the first one, I want to work it down to plain x and y's, and I can divide through easily by 4. So doing that, I'm left with x plus y equals 120. Now I have my simplified third equation. I do the same thing with the next equation. I can reduce them all by 20. And that leaves me with x minus y equals 24. And I have my fourth equation. Okay, 4 equations. Here we go. So number 5 rather, I'm going to add my third and fourth equation together. I do that because I can eliminate the y's that way. So x plus y equals 120 plus x minus y equals 24. The y's go away. I'm left with 2x equals 44. I'm going to divide through each side by 2 to get x by itself. X equals 72. That was pretty painless. Now I'm just going to take 72, x equaling 72, and I'm going to substitute it back into 3. And I do that just simply because looking at what each equation is equal to, I don't want to end up with a negative number. So can't end up with a negative speed, so I'm going to choose that one because I won't end up with a negative number. So of course, 72 plus y equals 120. I subtract 72 from each side. I'm left with y equals 48. Here's my x speed. Here's my y speed. So the speed of car A is 72 kilometers per hour. Sorry about that. And the speed of car B is 48 kilometers per hour. And there you have it. Interesting things. Now this lesson requires a lot of thought. So we are actually going to divide our assignments into 3 days, over the course of 3 days. This is the application of all of what we learned previously. So your first day's assignment will be page 64, number 1, 2, 3, 4, 5, and 6. If you have any questions at all whatsoever, please call and I will attempt to talk it through on the phone. And then I think because of the type of lesson it is, I would appreciate if you're still working on this over the weekend, after tomorrow, after Friday actually, because that's really today. I'm recording it the night before. If you actually have more questions Sunday night yet, have your parents text me so I have a heads up on what we need to do on Monday. Okay, thank you. Have a good day doing math. I'm always available until 3:30 today.